So first off, thank you very much for having me. I mean, RVAsec, this has been awesome couple days here. Just some fantastic speakers and a lot of fun out there. The capture the flag, the lock picking. So thank you guys for having me. And also thank you for having the GE folks. I know it's a ton of us running around here. And I'll explain a little bit why. So first and foremost, we actually have set up kind of a shop here, if you will. ISTC is what we call it, the Information Security Technology Center out in Glen Allen, Virginia. So right now we have about 120 folks out there, all security focused for GE, which is why you see about 30 of us running around at this conference, enjoying like the Friday off, if you will. And up there, and you can see the cool Fusion Center. I mean, we have everything you can think of: incident response, intelligence, digital forensics, architecture, solutions, you name it. In the Fusion Center, that's where my office is. We get to iris scan our way in there in the morning and get to work on intel and IR and really cool stuff that I'll be touching on shortly. With that said, a little bit about GE. Most people think we make light bulbs, refrigerators. Absolutely true. Absolutely true. And my house is decked out with all that stuff too. With that said, though, I mean, we're actually in a lot of other spaces. We're actually a huge industrial company. We're also in the financial area. So if you ever go to like JCPenney or even on Amazon.com, those credit cards and things are actually run by GE. So really, I think light bulbs is about 5-6% of our business. So just kind of keep that in mind as we go forward. And with that said, you're like, okay, who's this crazy guy talking to me right now? So I'm Sean Mason, Director of the Incident Response Team, the GE CERT for General Electric. And real quick, just walk through my background. Did start in the Air Force. Did 4 years there as a software developer. I'm not really dating myself, but when you join the military, they give you a job and you just kind of do what they say. My first job was actually writing COBOL in a VI editor. And I'm like, really? Like the .com thing was happening. All my friends that graduated programming school with me were all doing like ASP, and I'm like, really? But anyway, ultimately graduated to like the ASP area, did some development for a while, moved up into a leadership role, and ultimately moved into audit. And hopefully you won't hold that against me or start walking out, because I will make fun of myself by saying that was I thought I knew what security was. I was going through and checking if people changed their passwords. I had no idea what I was doing. It was checkbox compliance security, if you will, at its finest. Ultimately, left Monsanto, moved to Harris Corporation. Very shortly after going to Harris Corporation, the CIO tapped me on the shoulder and was like, "Hey, Sean, I need you to fly up to DC for this meeting. I need you to figure out this APT thing and let me know." I was like, cool, right? So I block my calendar, I get my flight, and I'm like, cool, I'll go up there, have this meeting, and I'll knock this APT thing out in 2 weeks, and I'll get back to work. 4 or 5 years later, I'm still working on that thing. It's not that simple. So that was really my first introduction into building out SOCs and incident response teams. Ultimately was recruited up at GE by our Director of Threat Management, who leads our Intel organization, and have been there for about the last 2.5 years. If you look at the little chart there, you'll see BRT manager, and people are like, what's a BRT? At GE, as I just talked about, we have multiple businesses, so we actually have incident response teams that sit in each of those businesses that are very close, very coupled with those businesses, so they can respond in kind. So actually I led aviation and energy's BRT, so roughly about 50% of GE's incident response team before ultimately taking the corporate role. With that said, we're gonna have a little bit of fun today. So, it was like day in the life of, and I could sit up here and I could tell war stories, and those are fun. But I didn't want to sit up here and spew FUD or talk about this, that, and the other. What I figured would be kind of more interesting, and one of the questions I always get asked is, how do you guys do X? How do you guys do Y? So what I'm going to do today is share a lot of the processes and things and details that we actually do day to day, that the men and women that we have at both the ISTC and the other locations that we have been working on. So I have built a couple slides in here, but for the GE folks in the crowd, you'll actually see a lot of your stuff just reused, because it's good stuff. So quick background, and I think it's important to talk about the evolution, because there was a pitch yesterday, I think the VCU guy, I believe his name was Dan, was giving it, talking about a SIM implementation. I was there a couple years ago at Harris Corporation, right? We got a phone call, and it was, hey, data's gone out the door, we see this going across the wire, so on and so forth. we instantly go into incident response mode, right? So we contract out, we start figuring out what that means, we start looking for data. That's great, right? But we said, hey, we need to go out and buy all these tools, right? So we need to throw in, SIMs and antivirus and I don't know, IPSs and vulnerability scanners, so on and so forth, right? And it's like, hey, great, we have all these tools, we have all this coverage, we can look at all this stuff. What are we looking for, right? And that's really where the concept of Intel came in, and I'll touch on that a little bit later. And I was reading an article, I think last week or 2 weeks ago, and I want to say the CISO of AIG was quoted, and it was like, the concept of Intel in cyber is really, year and a half old. So this is something that would still kind of new to us. I mean, I think we're very good at it, but we have a long ways to go. And then finally, where we're at now, I mean, we have the Intel capability, but where we're trying to get it is looking at it from a kill chain perspective, which I'll touch on as well. But how do we use Intel to really drive investment, to drive risk management for the corporation? So with that said, I mentioned earlier, GE is made up of many different businesses. And as such, we see pretty much everything you can think of. Be it hacktivism, like Anonymous, we do track those folks on a very regular basis. We keep our eyes on them. The advanced persistent threat, and I was told every time I said that I had to take a shot, so just count them and I'll drink them afterwards. Rocky, thank you. So we do keep track of APT in those campaigns. And then finally, cybercrime, right? So actually my cybercrime leader's in the room. And we keep an eye on those guys as well, right? So especially think about capital, right, being 30% of GE. We have to be very cognizant of that. So long story short, sitting at the corporate level, we really see everything. So it's kind of cool. I touch on the kill chain, and you'll hear me say kill chain, kill chain, kill chain, kill chain as I go through this pitch, and that's like the thing that we just walk around all day talking about. So kill chain is a concept that was brought up by Lockheed Martin, Mike Klopper, Eric Hutchins, and Rohit Amin, I believe. Fantastic folks. Eric actually gave an hour-long pitch at RSA this year on kill chain. So I'm not going to go an hour deep into the kill chain. But long story short, it's really looking at attacks and saying an attack doesn't just happen, right? There's actually a lot of different steps that go into it for an attacker to be successful. And something I hear all the time is, this asymmetric warfare concept where, we have to protect everything and they only have to be right once. Fair enough. But when I start looking at an attack from a kill chain perspective, they actually have to be right quite a bit. And in that kill chain, as you go through the phases, there are a lot of opportunities to either stop them or detect them. So you'll hear more about the kill chain as we go through. And then starting to jump into the incident response stuff here. Really, we look at it from a DCAR perspective. So detection, collection and containment, analysis and remediation, always with the foundation and the fundamentals of Intel at the heart of it all, right? So everything's driven by Intel. And as you go through, at a high level, detection, what's going on in the environment, contain and collect, right? So when you do find something, how do you stop it from beaconing out, from working? How do you go around collecting that forensics evidence? Ultimately analyzing all that information, and then finally remediating, recovering from it. And I don't mean just short-term remediation either, right? So how do you understand what happened wing to wing, and then what can you do to affect long-term? What's the state of the environment? Another question I get asked a lot is around metrics. I will say at the highest levels, these are the metrics that we truly care about. We track tons of other metrics. We track alerts. We track, how long does it take somebody to look an alert and process it. We track volume of incidents. We track, this, that, and the other. It's good stuff, right, at the operational level. But at the highest levels, at the end of the day, the key things that we are concerned with are dwell time. Dwell time being the time that the attack actually took place to when we actually contained it, right? To reporting it. And then ultimately the contain time, like how long from report to contain, right? So dwell time, for example, right? You'll hear a lot of the Verizon breach reports and this report and that report that, it takes 180 days, 2 years to find something. To me, that's unacceptable, right? And that is something you really have to track. And I will tell you, when you first start tracking it, you're just going to shake your head. It's going to look ugly, right? Because you're going to find a lot of legacy stuff in the environment. And as you get better, as you get more protections in place over time, as you get more detection in place over time, you're ultimately going to see that number start dwindle down, right? So it's something we stay very cognizant of. The contain time piece, I hear a lot of things. I hear 1 hour containment. I think GE was very famous for that. I will say 2 things on that. One, I think it drives the right behavior, right? 1 hour, it's a good goal, but I don't think it's perfect. There's always different factors that go into what's happening on an attack. Is it really reasonable to bring down a domain controller within an hour without thinking about what the impact is to your business? Probably not, but you probably have to get some other protections in there. But based on the attacks we see, based on attackers these days, they move at lightning speeds. They could be in, and within seconds, your stuff could be gone. So you absolutely have to figure out that contain time piece, keep an eye on it, and continually drive that thing as close to zero as possible. And then I think this is the final fundamental, or 2 final fundamental slides. One of the fundamentals is workflow and knowledge management. So first and foremost, we track everything in a wiki. I love the wikis. We throw all of our information out there, be it write-ups on hosts, be it write-ups on incidents, be it alerts in the console that we see over and over again. All sorts of information, all sorts of goodies are out there, even our processes as well, right? So we track a lot of our stuff there. Going down a box there, you'll see RT. If anybody here is familiar with RT, we actually use that for our workflow management system. So think about it, back to that DCAR concept, right? So we detect something, we go out and collect it, we analyze it, and we ultimately remediate. Well, there's a workflow there, there's a process, there is a handoff, right? It's not just one individual doing all that stuff, especially at GE's size and scale. We have an army of folks doing this stuff. So we utilize RT to help us manage that. Ultimately, if we do find something, we actually have an in-house system we built called IMS, Incident Management System, so we kick it up there. And ultimately, that's where we have kind of our ticket tracking, and we go into a little bit more detail. And then last but not least, our repositories, right? So we have all this great code, all this great stuff out there. How do we share it? How do we keep it current? How do we make sure the versions are good, so on and so forth? So we actually use Git for a lot of that stuff. And then the last, but definitely not the least, fundamental is communication. I cannot stress enough communication. I actually had a tweet one time, and it was something happened, and I was just like, I just tweeted communicate, hashtag defer. There's nothing more important you can do. So first and foremost, how do we communicate? We tailor our communication based on the kill chain, right? So if it's KC1 recon, I might actually get an email from the Intel team saying, hey, we're seeing so-and-so do X, right? To me, that's a heads up, right? That's like an early warning system, right? Because that usually means that something may be coming down the pipe, right? So our guys can get ready and kind of be a little bit more vigilant. Now, if you get down to like KC6, KC7, when you're talking command and control and you're talking about actions on objectives, you absolutely need to kick up that communication. And with that said, when we do kind of get down to that level, we do start talking around a standard communications rhythm. So our leadership knows, the folks out there working on this stuff knows that within about an hour of declaring an incident, and I chuckle a little bit because incidents are very fluid in that first hour. Usually it goes a little bit past that. We do our best to get a communication out so everybody is aware of what's going on. Because it's surprising. I mean, you might get a phone call and it's like, hey, so-and-so are skipping meetings. Well, they're a little busy right now. And then we do a close of business email every day. So everybody can expect, on their iPhone, on their BlackBerry, to have something as they're either going home or whatnot to read it at night and get an update on what's happening. We do tailor that, or I should say, trail that off a little bit based on what's happening, and say maybe it's day 3 or 4 and we're still kind of working on stuff. Maybe we're waiting on this, that, or the other. We may say, hey, we're going to send something out in 2 or 3 days, but we let folks know. And then at the end of the week, we actually have a weekly, what we call a CISO council call. It's where all the leaders of security across all the businesses get together. So we'll actually compile a large I wouldn't say large, probably 3 to 4 slide PowerPoint, and make sure that gets out in front of them so they can ask more detailed questions. But keep in mind, they are also getting emails during the whole week of keeping them up to date. So actually it plays very well. They can ask a couple more detailed questions, and there's usually more questions around what should we be doing, right? And last but definitely not least, I talk about leadership. Obviously the incident response teams need to know. But to me, it's about transparency and inclusiveness, because if you hold this information close to the vest, being an incident response or an intel team or whatnot, you're never going to get anywhere. So we actually include our solutions folks, our architecture folks. That way they have awareness of what's happening in the environment as well, because ultimately they're going to be the ones that are going to help us protect the company at the end of the day. And then this is actually a template of what we use. This is a standard form. We've used it for really a couple of years now. It's pretty simple, though it can get a little bit detailed depending on the incident at the time. But this is all it is. I mean, it's straightforward, right? So you can see kill chain phase. Once again, kill chain, kill chain, kill chain. Businesses and locations impacted. Like for us, that's kind of a big deal considering we're pretty global. The summary and the impact, right? So the impact, and this is one of those things we continually try to get better at. The impact is not, a server is down, right? Well, what was that server doing, right? Is there an impact to a customer? Is there an impact to revenue, right? So we need to get a little bit better at that. Incident status as of, XYZ date and time. And then we go into a little bit more details down with the host status. So that's getting down to the granular, hey, we got 2 boxes here. They're either pending LR, they've been cleared, they've been compromised, so on and so forth. We absolutely include the intelligence summary. One of the first things I'm always asked is who did it? And, Intel is off there working their butts off trying to figure that out for us. And we absolutely need to include that in there. And then finally, action items and the next update. So, hey, what are we still working on? And then finally, when can you expect to have an update again, right? So with that said, getting into the Intel piece, because I think Intel drives the whole thing. So I started there. As I mentioned, GE, we do a lot of things. And with that said, we are in one form or fashion in every critical infrastructure piece there is. So with that said, we have very close ties with the government, different agencies out there, so we partner very closely with them. There's that sharing of intel, the indicators, so on and so forth, that will help us do our job. And in return, we give them some information back to help them protect themselves as well. Trade associations, right? So like the ISACs, great example there. So we're ultimately going out there, sharing information with those guys as well. Tons of those. And then finally, the industry and open source. When I say industry, I really mean our partners. And when I say our partners, I mean other companies that are like-minded that we may have NDAs in place with, right? So we may literally be able to have a phone conversation about, hey, we're seeing X. Do you guys have any idea? Hey, we saw that too, right? Start putting your heads together. It's better than us just being, kind of blinders on. And then open source, I mean, Twitter, Google. It's amazing what you can find out there. Funny story there. Actually hired a housekeeper like a couple months ago to help us out around the house. Didn't think much of it. Nice lady comes in. Okay, wasn't quite working out. And then the wife, and this is where I fall down. She gets on Google and starts Googling this lady and finds out she has a criminal record for theft, right? It is amazing what you can find out there, and shame on me for not doing that part, right? So long story short, Intel, it comes from all over the place, and it is very important to have that, because that's going to ultimately feed into the rest of the processes here. So I'm going to talk a little bit about CRITS. So CRITS is actually our Intel Storage and Analysis database. We actually have Bill Brinkman back here, who's a big CRITS guy. So CRITS is actually something that was developed by MITRE. It is free out there. I think there's over 120 folks out there that have it, or companies I should say that have it, and it really helps us track our indicators, our intel, wing to wing. So just to give you guys an idea, and hopefully you guys can see this from the back. I know it's a little bit small, but really when you get into it, I mean, you see badguys.com as the indicator there. You can see when we found it. We also have a confidence and a impact score, right? So I think right there is a high medium. So it gives us an idea, how important is this indicator to detect on, and if it does fire, what should we be doing with it? Let's see. The next piece here. We'll go down to activities and tickets. Activities, and we're still building this out. We are not perfect yet. We have not finalized everything. There are a ton of change requests coming in, and our developers are actively working on this stuff. But the activities piece is essentially where have we had this deployed out, right? So have we deployed it out into our SIM environment? Have we deployed it out into our HIPS environment? Have we deployed it out into our IPS environment? So we can start tracking these indicators, track where they're at, where they're deployed, and then ultimately two things. One, understand if we have coverage across the board, and two, maybe we have duplicate coverage as well, right? And going a step further, which we haven't done yet, is once these indicators start firing off, I'd like to pump that data back into here. Tickets, that goes back to that IMS system, right? So have these indicators ever fired? Have we ever actually had to respond to these things? Campaigns, folks are familiar with the term of campaign or threat actor. So this is, who is this attributed back to, right? Activity, right? So relationships. The easiest way to describe a relationship, I think, is a fish, right? So a fish comes in, you're going to have a subject line. That is an indicator, of course, right? But there's also going to be a from. There's going to be perhaps a link embedded into the body. Maybe there's a PDF file with a name, right? Maybe there's stuff in the PDF. So here we can start actually mapping relationships between indicators to each other, right? And the reason this is important is because down the road, let's say 2 months down the road, maybe you get another fish. Maybe there's nothing the same except for one little indicator. Well, now you find that out here, you can map that back, you can figure out what that campaign was that was shooting it off. And then finally the objects piece, I mean, that goes back to the kill chain, right? So you can see here C2, so immediately we can kind of get a better understanding of what the impact is. So going into detection, you'll see detect in the middle there, and I put that there for a reason. It's not a detection-driven response team that we have. It is an intel-driven detection team that we actually have now. So the key here being it's a continuous process. There's a lot of work done on the intel side in terms of quality checks, in terms of enriching those indicators, and in terms of making sure that they're ready to go and get deployed. Ultimately, before they come into the detect team. At the detect side, first off, we do the quality check. We see where we can actually put them in the environment, if it makes sense. Maybe we already have coverage in one form or fashion. Ultimately, we'll develop those signatures, test them before we put them out in the environment, right? So we have kind of some QA labs, and then ultimately put them out there. So we talk about detection scenarios and we talk about the kill chain, right? So first and foremost, what we've done is we've actually laid all the indicator types that we have against the kill chain. And we said, okay, at any point in time, this is what we can catch where, right? But this has nothing to do with the tool. It's simply, really, this is a database, and I need to talk to Bill because this is something I want to build inside crits. What this lets us do is then we can jump in and say, okay, for our NSM solution, we can look for all of this stuff minus the things that we've crossed out. And I didn't put all the slides in here, but we've done this for every single platform that we have, right? So now what you can do is you can start stacking this stuff on top of each other and understanding, do you have overlapping coverage? Do you have perhaps a gap? And whatnot. So you can actually start driving your detection based on this. And I think, for example, and this is purely an example, right? So if I came back and I said, look, I have no way to detect, I don't know, weaponization is a good one to pick on because it's very rare that we actually are able to pick up on that. Or C2, for some reason, if we couldn't find an IP address, these are things that we would have to go back to perhaps the solutions team, the architecture teams, and say, hey, we need some help here because there's no way that we can detect these indicators in our environment. And then another example here, same concept here, but looking at an actor, right, looking at those campaigns that we now have in crits, we can actually pull out and say, hey, it's great, guys, but for campaign XYZ, we actually have no way to check out, find the C2 in our environment, or if they're installing anything. So can you guys go beat the bushes and find some of that intel for us so we can consume it and ultimately get it out there. So with that said, I'll move into containment and collection. I guess I'm looking for a show of hands. Who's tried to ever collect forensic evidence from somebody working in a tent in the middle of Africa? Hey, I got 1, 2, 3. Awesome. Awesome. How about on an oil rig in the middle of the ocean, right? Okay. Point being, being a very global company, and I have heard everything, and it's craziness. It's not as easy as you would think to collect that forensic evidence. One of the things that we found actually works for us is we actually have Outpost servers deployed across the world. Very simple servers. I mean, it's just hop on it, you spin up a Windows VM, and from there, as I'll jump into it, you can actually log into a suspect machine. So say you had something over in Asia, the closest and best thing may be the Singapore server. We may hop onto that Singapore server to be a little bit closer to that box. It's not perfect, but it helps. Ultimately, when we log into that machine, first thing we'll do is contain it, and I'll talk a little bit more about containment stuff here in a bit. But then we'll have an auto upload of our LR, and I will talk about the LR in a little bit. But basically, it's the forensic evidence, right? So we'll click a button, we'll contain it, and we'll shoot it back up to our SSH server, which ultimately gets pushed back into our centralized analysis and storage servers. And then for really odd and rare occasions, we do have an external server as well, in case somebody's off the wire that we need to collect. So containment. I guess the first thing I'll say is not all incidents are created equal, and as such, not all containment options should be created equal. So first and foremost, we need to figure out what the host is and system type. And when I say system type, I mean like laptop, desktop, server. Though it's very rare I see a desktop anymore. Identify the operating system, right? Is it Windows? Is it Mac? Is it Unix, right? And then we also, is it online or offline? A lot of times we'll come across an alert. It's no longer to be found on the wire. What are we going to do? And sometimes the user's on VPN. So with that said, we actually crafted, and this is a little example here, we actually crafted multiple methods to handle all of these situations, right? So if somebody's on VPN, we can actually contain that user without knocking them off VPN and still collect what we need to do. If they're offline, we can actually put a containment solution in place so that next time they do log in, they'll be contained, so on and so forth. And I'll talk about 3 different containment solutions we actually have. So first one is virtual isolation. This is the this is a no holds barred version of containment. So basically this says you can only talk to a couple domain controllers, and these are usually the local ones or the ones it's been using. You can only talk to on a couple ports across the GE network, and that's really more for sustainability. And back to the Outpost conversation, you can only talk to our Outposts. We don't want you talking to anybody, right? So this is locking it down for good. And it's real simple. It's a couple lines in a batch script right there. We just drop it on the box and go. Yeah, go ahead. It's at the host level. Yeah, so we do have a couple of network level containment options that we use, but we try not to use those simply because, back to my earlier comment about I haven't really seen a desktop in a while. Great for servers. Laptops, they pick up and move in a heartbeat. And then quarantine. Quarantine is something that it's like virtual isolation, but it's like its ugly cousin, if you will. So we actually allow the computer to still talk on the 3-dot network. And I'll use an example. How about configure? Okay, configure, it's a little bit nasty, but it's truly not gonna, lead to a true big incident at the end of the day. So we may quarantine a box, which says, hey, Joe user, you can still keep working, right? But they're gonna know that their machine doesn't quite work as well as it used to, and we're gonna give those guys a call and work with them to clean that machine up, right? So it locks them down, contains it a little bit, but not to the nth degree like a virtual isolation. And then the things in pink, we actually designed it in such a way that they could actually VPN and continue working. And I'll tell you that took a good 6 months of working with our vendor on figuring that solution out. And then the final one, and this is something we actually have only used once in production, but it worked like a charm, and this is the great one for if something is offline. If it's offline, responder is going to add into the group policy object, hey, this machine, when you see it next, lock it down, right? So guys goes home for the day, we see an alert, we respond to it, we throw them in the GPO. Ultimately, they come back online in the morning, they're contained, right? That's going to alert us, and then back to the earlier conversation around Outpost, we can jump on that thing, get on the suspect, and then pull back the data. The other cool thing about the GPO is not only does it isolate, but it actually changes the desktop background and actually changes the login banner. So it's something like, please call the GE cert immediately, you have an issue. So jumping into analysis, the first thing I will say is invest in your analysis infrastructure, right? A lot of folks want to just jump right into SIMs, and they want to jump into antivirus tools and this tool and that tool. We actually spent about $50,000-$60,000, I think, on analysis server. It is a beast of a server, and it allows us to do a lot of things. And one interesting data point is we had an MFT 6 hours before, we dropped down to 30 minutes, and there's a lot of other examples like that. So think about it. You come in, you find something at noon, right? Gets escalated up the chain. Okay, you grab the evidence, from the guy in, out in the middle of Africa. Took a little while. Okay, it gets back at 2 o'clock. If you don't invest in your analysis infrastructure, now you're looking at a minimum of 8 o'clock at night before you get something back. It's not really acceptable. So absolutely invest in your infrastructure here so that you can ultimately parse through these live responses. So I've said live response quite a bit. One of the questions I get asked is, why don't we use this tool or that tool? That's an agent that's sitting on a machine that you can probably just pull forensic evidence from. And I'll say my first answer to that is I don't trust that machine, right? I don't trust, what's going on it. I also don't trust necessarily the health of that agent as well. And the third thing, interesting enough, is that given our environment, given the fact that we have pretty much any operating system you can imagine from pre-Windows 2000 until today, we need something that we can pick up and drop on a box and not have to wonder if it's going to run or not. And I will also say that we've actually given this to some third parties who have sought our assistance. Works phenomenally in their environment as well. So this is a custom built package in batch, if I'm not mistaken, that basically grabs the RAM, page files, MFTs, the Hive, so on and so forth. You guys can read through there. Ultimately compresses that for transport back to the mothership, if you will. Once we get that back, and this is something the guys just redid, we used to have something called a streamliner, which would go through and parse through it, but they kicked it up a notch with this the Fire product that they just rolled out. Leveraging that analysis infrastructure that we've invested in, they're able to execute in parallel all these sub-processes. And these sub-processes are essentially unpacking the LR, right, and then processing through the MFT, the memory, running Yara scans. So we actually have a lot of our signatures deployed into Yara that just go through and run through it, and ultimately pulling up a timeline and coming up with our default wiki page. So before an analyst even looks at this thing, you have all sorts of artifacts just sitting there waiting for them to get to work, with possible hits that they can go right into. And then final couple slides talking about remediation. So first off, prevention. We leverage intel, detect, and response across the board to really affect architecture changes, solution changes, you name it, right? We learn from our adversaries, we learn from our attacks, we learn from our incidents. We obviously do root cause analysis. I think that is important, but a lot of times I think folks make a mistake and they say, hey, the root cause is an unpatched Java. Okay, to me that's a little bit of a cop-out, right? There's always going to be a vulnerability on a box, right? And the answer can't be just patch everything. So what we actually do is we actually go through and pick apart the incident in what we call a failure mode analysis. And what we do there is we go 5 whys and what's deep, right? So why did this happen, right? Well, the server was unpatched. Well, why was it unpatched? Because we didn't patch it, because we didn't get around to it. Well, why didn't we do that? Well, because somebody was on vacation. Why were they on vacation? Well, so on and so forth, right? And you ultimately get to the root of the problem. So to kind of walk you through one of our templates that we use, and we do this pretty much on a weekly basis here, we have a task force that gets together and we talk through things that we're seeing in the environment, is we break it out by kill chain and we dissect the incident. In this case, we actually had an external facing web server. It was popped. I want to say it was actually a Joomla vulnerability, and I think if you would have looked at the time when we saw that, I think you probably would have saw 20 Google searches for Joomla. It is a content management tool of some sort. But you can see, to start with, we didn't pick up the reconnaissance activity. So back to my earlier point, we didn't have that early warning, right? We weren't aware of what was going to happen. They actually ultimately had a SQL injection attack used against us. So we figured out, hey, we couldn't look at the SSL traffic, and like most folks, we had the flaws out there. So a couple items there for mitigation actions, and then jumping down to actions on intent. And this was where they actually found some passwords in an id.txt file, right, that were just sitting out there. It was part of an admin script at one time. No big deal, but it failed to delete itself, right? And it just kind of left those jewels out there, if you will. So we figured that out and ultimately retired it. And we also scanned the entire environment to make sure those files were not resident anywhere else, right? So if we would have just stopped at the root cause, we would have said, okay, hey, it's a Joomla vulnerability, right? Let's patch Joomla or retire it or whatnot. We wouldn't have dove into it and started figuring out all this stuff. And one thing I will say, I wanted to get the slide in here, but we haven't quite perfected it yet. We haven't finished it yet. But ultimately, these things here, there's some very tactical things like the scripts being retired and scanning the environment. But there's also some long-term things in here as well, like secure development and application security assessments. Right? That's going to be a little bit longer than a couple weeks or a month. So what we have in the slide I couldn't put in here was what we're going to call the security game board. So how do we affect long-term the environment with more strategic type projects? So finally, putting it all together, what we have is really just an ecosystem, right? From the intel coming in from crits, we've automated, we have manual processes get out into our tools, ultimately flowing into our single pane of glass, ultimately firing on suspect hosts, which we can jump onto in an automated fashion, pull data back through our fire scripts, have data sitting there for our analysts to look at, and then document and workflow across the entire process. So with that said, in conclusion, Intel and IR work, it's definitely a process. It's not magic, it's not voodoo, it's not unicorns jumping around. You can measure it, you can evolve it over time, and you can simplify incident response. Partnerships and open source Intel are absolutely paramount to success. Having blinders on and just thinking that you guys know everything or we can figure it out ourselves, it's not how you're going to be successful. And then detection, right? It's not about detection for detection's sake. It's about detecting on what's important to you. It's about detecting on what Intel is seeing, and ultimately looking for that. Or if you can't look for it, understand where you have some capability gaps, right, and address those gaps. Containment, there's no one-size-fits-all model, right? It should be based on risk. And then I can't stress enough investing in your analysis infrastructure. It reduces time, right? If you get a box back and it takes you 8-10 hours to process through it, who knows what the attackers could be doing, right? If you can figure that out in 30 minutes, you may be able to get ahead of them. And then communicate findings and learnings back to the other teams. Incident response is not about, an elite team of folks sitting together and keeping things close to the vest. You have to get those findings out to other teams so that they can help you at the end of the day. Finally, it's all about building a thriving ecosystem for your company. So with that said, I think we have time for questions. And wow, cool. I guess I am done. Sorry. With that said, once again, thank you guys. I appreciate all the questions, and I'll hang out up here for a little bit if you want to ask some more. Thank you.